Okay, so I thought I'd record this video for you folks in case you were stuck. And this is a variation on one of the homework exercises, one of the exercises in the quiz. And what they're telling us is that we've got two forces that are working on each other, pulling on the same object. One has a magnitude of 100. That's the force being exerted on that object, and it's at an angle of 37 degrees. And then the second force is exerting 65 pounds of force on the same object, and that angle is headed off at 145 degrees. And we want to find out what the result is by those two forces acting on that object. And if we use that parallelogram drawing, like you'll see in physics, or they've shown you in this course, um, you can draw those two angles. Then you do the tip to tail trick. You take this vector and you add it to that vector. And notice these are parallel. They should be. And then this vector gets moved up here and headed down there to that vector. So you put in the tip's tail. And then you connect that diagonal, and that's what the result will be. So how do we calculate the magnitude and the direction of that resultant force? Well, let's see. So what we're going to do here is, first off, we're going to break these vectors that have an angle and a magnitude down into the horizontal and the vertical components. All this is right triangle trigonometry. So if I want to find that x length, it's the same as the cosine. Remember, cosine is x over adjacent, and of course you've done this as far as coordinates in the unit circle and all that stuff. So cosine of 37 equals x over 100. That means it's 100 times the cosine of 37. And if you calculate that on your calculator, make sure you're in degree mode. That'll give you the horizontal component, or the x coordinate of that force. They call it the horizontal component because it might not necessarily be on the x-axis. Long story, we won't worry about it. So then to figure out the vertical component, or the y, I want to put that back. It's the opposite over hypotenuse, so it's the sine, and 100 times the sine of 37, that's the vertical component, and calculate on the calculator. So that is this first force, this first vector broken down into its horizontal and vertical components. Now we have to do that same thing with the next vector. And what I did is, well, let's deal with the x. That's what I wrote first. I found the reference angle, and you don't need to, as I'm going to point out in a minute. I said, well, the cosine of 35 equals x over 65, which is x over the cosine of 35. But of course, in this quadrant, x is negative. So I've got to remember, once I calculate that, I got to make it negative. But the cool thing about it is you don't have to actually find the reference angle. You can just do the same thing with the angle that they're telling you it's at, which is 145. And if you were to type in 65 cosine 145, the cosine's negative over there, and it knows. And so that's the horizontal component. To do the vertical component, same thing. I said the sine of 35 equals y over 65, but I could have just done, and then you multiply by 65. Or I could have just done 65 times the sine of 145, because the sine of 145 is the same as the sine of 35, because they're both, if you think about the unit circle, changing gears, the sines are both the same sign in quadrant 1 and quadrant 2. So that worked out to be 45. So there's the horizontal and vertical components for this force. And then we want to add them together, and that's what that diagonal does. So here's force 1, here's force 2. If I add the horizontal components together, I get the 26.619 number. Add the vertical components together, I get that 106 point whatever number. So that's the horizontal and vertical component of the resultant. And then to get the magnitude, as you probably remember from the formulas, you're going to square the x, square the y, square the horizontal, square the vertical, add them together, take the square root, Pythagorean theorem. So that is the magnitude of that resultant force. To get the angle, the direction, we'll do the opposite, the vertical component divided by the horizontal component, and find the arctan of that. It worked out to be 75 degrees. And then if we look at that resultant, I could be easily convinced that this is a 75-degree angle. And if that's 100, I can, and this is the longest side in this triangle, that has to be more than 100. 109 certainly seems like a reasonable number. So hopefully that helps you solve these kind of questions.